Hi, my name is Ryan Kopinski. Today I'm going to show you how to build a multi-user AR experience using RealityKit. Let's get started. Okay, so the first thing we're going to do is create a new augmented reality app. By now, this should be easy for you. We're going to call this multi-user AR sample. And we're going to use language, it's going to be Swift. Content technology, we're going to use RealityKit, like I mentioned. And then the user interface is going to be storyboard. We'll click next and create the project. Okay, so this should be familiar to you. If you're new to augmented reality development, I suggest you look at my basic AR app tutorial, which I'll link up here and in the description below. The first thing we're going to do is I'll take a step back. I actually published a video called Pew Pew AR, and it is a multi-user or a multiplayer laser tag app in augmented reality. And several folks actually reached out to me and asked if I can do a tutorial on how to do a multi-user AR experience. Now, I used Apple's sample code where they show how to create a collaborative session using RealityKit. I'll link that in the description below. And so this project and this code is based on their sample project. And so the first thing we're going to do is we're going to create our laser. So we're building a laser tag app. It's going to be a simplified version of what I built for Pew Pew AR. And so the first thing we're going to do is we're actually going to build our laser using Reality Composer. So I'm going to open up Reality Composer, and this is what it looks like. Now, the default experience that comes with a default app is just a cube. We're going to remove this. And what we're going to create is we're going to create a pill-shaped object. Let's see, okay. And then what we're going to do is we are going to make the diameter 1 centimeter. And you can play with the dimensions and make it any dimensions you want. But this is what I did for Pew Pew AR. And so here we have our a white laser. Now we're gonna put it at the origin. So the position is all 0. And then for the rotation, the x-axis is -90 to make it horizontal, pointing forward. And so the final thing that we have to do is to make it red, because I'm gonna create a red laser for this example. There are a few other things that I also would like to show you. First, we're gonna name our scene. We're gonna name this scene laser, and you can enter the name in. So if you don't have any objects selected, you can enter the name in. If you select an object, you can actually also rename it. And so I'm gonna call this laser red, just for organizational purposes. Once we have that, then we're gonna add a behavior. So what is really cool with RealityKit and multi-user experiences is once you have the multi-user code running, it also automatically includes the animations. So shooting a laser is automatically synchronized among devices once your shared session is running. What we're gonna do is we're gonna create a very basic behavior of type custom. We're just going to create a custom behavior and call this laser. For our trigger, we're going to use scene start. So the moment the laser scene loads, we want the animation to start. And what we're going to do is we're going to select for the action move by, because we want to move the laser forward in just one axis. And I think this in this case is going to be the y-axis. The duration, we're gonna, I have to step back. There are a few things that we have to set up for the move by animation to actually work. The first thing we have to configure is affected objects. Now you see here that it says none. And so what we have to do is we have to select it, and now it says one object. So then we have that. Then the duration, we're gonna create 0.5 seconds. For ease type, this is how the animation starts and ends. We're just going to do ease in. So we're going to accelerate, and then we're going to keep that acceleration. And for precision, we're not trying to move the laser sideways in the X direction. We're trying to move it forward in the Y direction. And so I'm going to create it at, I'm going to create this as 500 centimeters, which is 5 meters. And the rest we're going to keep the same. Now, one thing I also want to do is once it hits that 5 meter mark, I want it to disappear. Because a laser just doesn't stay in the environment, I just want it to remove. And so what I'm going to do is, in this case, it's already selected. The duration we're going to do at 0 seconds, so I want to instantaneously see this happen, and then we're done. We're not going to do any motion type. And if you want to see how this looks in Reality Composer, what you can do is you can play it in the action sequence right there, which is really cool, or you can actually play it over here, which is more of the scene. So you can actually play the scene, and you can play and stop. So this is really cool. So now we have our laser. What we're going to do next is we are going to export this scene. And the reason why we want to do that is we want to use a reality file for this. So we have the option of using the RC project, but I want to show you how to use the reality file. And so we're going to go to File in Reality Composer, File, Export, Export Current Scene, and then we're going to create a reality file called laser red, and we're going to export. Okay, and so now that we're done with this, we're going to close it and we are going to move on. And so what we're going to do now is we're actually going to create a quick basic AR app. Now I'm going to go a bit quick because I've done a previous tutorial on this, and so if it's too fast, just watch my previous videos for that. Okay, so what we're going to do is we are going to remove the default code, which is the view.load that we've had here. We are going to remove that. And then what we're going to do is we're going to import the laser red reality file that we just created. And so I'm going to add new file here. And there it is. And I'm going to add it. And when you select on it, you see it animating automatically. So we know it works, at least the animation. And you saw how simple it was to actually just animate the laser. You know, without any code, I have a, you know, kind of like a bullet firing off. And so that's very cool. Now, to get multi-user working, we're going to have to use RealityKit. And I've also used it in my basic AR app for this specific reason, because that's what we're going to use now to create the multi-user, or part of the multi-user interface. What we're going to do next is, so the first thing we're going to do is import RealityKit. Then what we're going to do is we are going to override our view.appear. Now, I've seen some sample projects that use view will appear. Sometimes I have issues with things kind of being glitchy, and so I use view.appear. Some of this code you can also put in view.load. I just use view.appear. If you want to have a production AR app, you want to be mindful of where, in which lifecycle method you put this code. Okay, so we're gonna just override, we're gonna implement our super, animate it. Okay, and now the first thing we're gonna do that I also did in my previous apps is we're gonna say setup AR view. I like to create a specific method to do that, and so we're gonna actually do that. So setup AR view, and this is actually really simple to do. So the first thing we're gonna do is we're gonna turn off automatically configure session because we want to have a custom configuration. What we're going to do is create a new config file, or a new config, which is an of AR world tracking configuration. We want to enable plane tracking or plane detection really, and we're going to make it horizontal and vertical. We're not actually using any of this for the laser shooting game, but you know, just add it in. It won't hurt. And then environment texturing, I do to automatic. Again, for this game, we're not really using that, but if you're creating a multi-AR experience to show objects that actually need proper reflections and lighting, then you want to do that. And then we are going to AR view session run. our config. Okay, so we have that. Now, once we have our setup AR view, the next thing we want to do is for PewPew when you tap on the screen, anywhere on the screen, it shoots a laser from the center of it. So essentially where the camera, the orientation and the position of the camera, from there it shoots a laser object. And so essentially what we're going to do is we're going to create a tap gesture recognizer to know when the user has tapped on our AR view. So UI tap gesture recognizer. I'm going to do target. We're going to do target self. And let's see. Okay, and we're gonna create a selector. So this is an Objective-C way of doing things. Handle tap, recognizer. And then we're gonna add this to our AR view. So our AR view is gonna be listening for this gesture, tap gesture recognizer. Okay. Now it's gonna give you some errors here because obviously we haven't defined our handle tap function. So we're gonna do that right now. Handle tap, so func handle tap. And then we want a recognizer, UI. Let's see, what do we want this to be? We want it to be a UI tap gesture. Autocomplete wasn't working for some reason. Okay. And so when we tap on our screen, what we essentially want to do is we want to place an anchor. You don't want to actually place the laser yet. And the reason for that is we're going to place an anchor, which is then synchronized over the network. In this case, we're going to use Multipeer framework by Apple. And the anchor is essentially synchronized on all devices, and then each device attaches an object to that anchor. And that's why it's so important to attach it to an anchor. And so we're going to create a anchor, which is just an AR anchor. This is an ARKit anchor, not a RealityKit anchor. And then we're going to do a name, which is laser red. In this case, I'm naming it the same string as my file name. That way it's easier to load. And then what I want to do here is I want to use my camera transform. Okay, and so the reason why I want to use my camera transform because I want to use the orientation and the position of the camera to essentially attach the anchor, and from there the laser will animate and shoot. And then we're gonna attach this anchor to our session and add anchor. And so we're really gonna add the laser object in our session delegate method, which you'll see very soon. Okay, actually we're gonna do that right now. So what we're gonna do now is we're gonna create an extension to our view controller. And we are going to implement, or we're gonna conform to AR session delegate, okay? And the method that we want to implement is the did add anchors. Because when we add an AR anchor to a session, this delegate method will automatically fire. Now, before I forget, oh, we have an error. Okay, so because I use the selector, I should add an Objective-C keyword over here by the function. So make sure that you have this Objective-C, so add Objective-C before the function if you use this selector syntax. Okay, so errors are gone. And I usually forget this, so I'm gonna do this right now. We wanna set our session delegate to self. Otherwise, our delegate method will not be called. And I always forget this, and then the code just doesn't work, which is frustrating. Okay, so we're gonna implement our session did add anchors. Where's that? All up top. Okay, did add anchors. Now, what we want to do in this method is we really want to just place our laser when the actual anchor is the corresponding one, because you can have multiple types of anchors and different anchor names. So you want to check that we're actually adding an anchor that corresponds to laser red. And so what we're going to do is say for anchor in anchors, we're going to say if let, so if our anchor, so if let anchor name anchor.name, because the name is an optional, so it may not have a name. So that's why we're essentially if let unwrapping it that way. And so if it has an anchor name, and an anchor name is equal to laser red, then we want to add the laser into our scene. This is crucial. Otherwise, we're going to place lasers when we don't want to. And then we're going to create a function. Now, I'm just doing the signature of it. This function doesn't exist yet, but we're going to create it. Named anchor name. And we're also going to do for anchor. There's a reason why we want to pass in our anchor, and you're going to see that when we define that function. Now it's giving us an error. It's undefined or unresolved identifier. So let's create the method right now. And so for our place object, this is very basic AR code. Once you've created a lot of AR apps, this will come to second nature to you. Place object named, okay, we're gonna do entity name, string, and then we're gonna do for anchor, AR anchor, okay? So now we have our function, error should go away, or the warning should go away. There we go. So the first thing we're gonna do is we're now gonna load our laser entity, which can throw an error. So we're gonna do model entity, load, oops, named laser red. Actually, we can just do our parameter that we passed in. Or no, entity name, that's what it is. Entity name. Okay, then what we're gonna do is we're gonna create an anchor entity. And now this is a RealityKit anchor. Because we have to add that to our scene. So we're going to create an anchor entity from our anchor. Now this will position our RealityKit anchor in the same orientation and pose as our ARKit anchor. That's very important. Okay, and then we're going to do our anchor entity. We're going to add a child, which is our laser entity. And then we're going to add our anchor entity to our AR view, to our scene. There we go, boom. Okay, I think we should be able to run our app now. Let me set this up. Okay. So I'm building it, it's running. Make sure you do it on a physical device, because otherwise in a simulator, you're not gonna be able to run this. Okay, it's loading. Okay, great. So here you have my setup. And so what we're gonna do now is I'm going to shoot. There we go. So you can see that I'm able to shoot as I'm tapping on the screen. Now there's one thing I want to show you. Look at our memory, and as I'm tapping, it's increasing. And our frames per second are actually going down. And so the reason why this is happening is every time I'm shooting, I'm adding an anchor to our scene and I'm never removing them, even though the laser is being removed. And so you want to be really mindful of this, because your app can crash if you start to exceed certain memory constraints. And so what I'm gonna do, now this is a bit hacky, okay? This is just for the time being. In production, you wouldn't wanna do this. In production, what you wanna do is when the animation of the laser is done, you wanna send a notification, and that notification then essentially destroys the anchor or removes it. That's, I think, the proper way of doing it. But just, to make it a little bit simpler, our animation duration was 0.5 seconds. And so what I'm doing is, after 0.55 seconds, I am removing this anchor. That way, I'm doing garbage collection where it's not just piling up a whole bunch of anchors. Okay, so now we're gonna do the multi-user part of this app. Now there are a few things. I actually used the sample app from Apple and copied a lot of their code. Now their license allows for this to happen, and I've included it in most of my work. Now what we're gonna do is I'm going to add a Swift package dependency. I exported some of what Apple did in their sample project and made it a Swift package. That way I don't have to copy paste too much. And so if you'd like to use this, I will make it public on GitHub. And so you can use it, but it's essentially just Apple's code. So I didn't add anything unique to it. It's just Apple. It's kind of like a helper to make multi-user AR simpler. Now, I will also say that when Apple presented RealityKit, they had a very simple way of saying, multi-user, just a few lines, and you'd be able to do a multi-user setup. That apparently is not working, and so they've created a workaround where you really have to use ARKit and Multipeer, the Multipeer framework to send data over the network. And so I'm guessing that in a few months, this may be irrelevant and that it'll just be like 1 or 2 lines. So let's hope that actually is the case. Now, the first thing we're gonna do, as I mentioned, is we're gonna add a Swift package. I've created a link, and I'll include the link in the description where you can get this helper framework, if you will. Now, keep in mind, this is not my code, or it's not my original code. It's really just from the Apple project. And so I added in the link, and I'm just importing this. If you haven't played with Swift packages yet, it's amazing. I think it's gonna replace things like CocoaPods in the near future. So it's awesome. And then we're gonna finish it. And so we've added now our dependency, and I've called this package MultipeerSession, and the package is right there. Now you can look in the sources, and it's essentially, Apple's code. But I made some slight modifications to make things just a bit easier to use. Okay, so now that we have that, what we're gonna do next is we are going to import this helper framework that I've created. Import MultipeerSession. So we're not gonna import Multipeer connectivity because MultipeerSession already does that. So I added a little bit more functionality on top of it. Now, what we're gonna do next, a lot of what I'm gonna do right now is copy pasting. And I'll go through it and explain it. But a lot of what coding really is knowing what to use when, and to not reinvent the wheel. And that's also why organizations like Apple put out sample code, so you can get started and create cool apps like what I did with PPU AR. Creating the actual game is what's important, not not really the basics of it. And so what we're gonna do is we are gonna do 2 things. We're gonna now add 2 variables, and I'm gonna paste them in and explain them. Now, MultipeerSession, what we're doing here is we are, let's see. Okay, yes, so we're creating a MultipeerSession. That is something that is from the helper framework. And then we're also creating a session ID observation. Now this is a key value observation. And essentially what we're gonna use it for, you'll see it right now or soon, is to see when our session ID changes, to let the network know, hey, our ID has changed, so our identity has updated. if the app crashed and we restarted, or however the session ID may change, we always want to have our most updated ID on the network. So that's that. Now, just like we set up our AR view, what we're going to do now is we're going to set up our MultipeerSession. So set up MultipeerSession. And in this case, we're going to also create a function, set up Multipeer. Okay, and so I'm going to copy paste it, and okay, so this is the code. Now there's two parts to this. The one part is we're going to use key value observation to monitor our session identifier. This is so that any anchor that we add in the scene has our ID attached to it. And so this is, you create an observer, and then you monitor whenever that value changes. Now we're essentially monitoring AR view session identifier. If that triggers, then we get our session, and then we send our ID to our network of all the connected peers, because all the peers should know about this. Now you're seeing some errors because I'm using methods here that haven't been defined yet, but we're going to define them, and it'll be fine. Okay, and so then the second part, what we're going to do is we're going to look for other players via our Multipeer framework. And so we're going to create a MultipeerSession, and I've modified the constructor that Apple used to make this a little bit easier to use. The key here is that service name has some requirements. It has to be lowercase. It can only be up to 15 characters, I believe. You can only use alphabetic characters and dashes. And so there are some requirements. If you want to learn more about it, I'll add the link where it explains what name it can be. But it's really, for pew-pew-AR, it was pew-pew-AR. So it can be something like that, but it should be less than 15 characters. And then we have a bunch of handlers that will be called if something happens. So we have a received data handler, a peer joined handler, a peer left handler, and a peer discovered handler. Now, your app may not use all of these, but you have to implement them, even if they're empty. Okay? And so that's that. Now, what we're going to do is we are actually going to create an extension. Now, we're not going to conform to anything, but it's just a way of organizing the code. This is just something that I like to do. I'm not sure if other developers do it too. But view controller, so it doesn't conform to any protocol. So what we're going to do next is we have a few errors in our code up here, right? It doesn't know send AR session ID to, right? And so what we're going to do here is we're going to say mark, this is Multipeer stuff. Okay, and so what we're going to copy paste, and this is almost verbatim what Apple has, so I don't see a reason for me to actually type this out and just take forever. But we're just talking about this. Now, being a coder means you transform things, you combine things, you remix them, and this is essentially what we're doing now. Okay, so send AR session ID to, we're going to send it to the peers. Now, what this essentially does, it creates an ID string, a command, and then you send the command data, which is encoded in UTF-8, and you essentially send it to the peers. Now, this is using a method that's defined in the library, in the helper library. Now, the more fun stuff starts now, and so what we're going to do is we're going to copy paste all the handlers that we used. Or that we essentially provided in our MultipeerSession. And you may be wondering, am I cheating by just copying everything? No, I'm not. This is essentially what Apple was supposed to do with RealityKit to make it really simple to do multi-user. And I'm trying to make it simple for you by showing you that I'm not doing anything rocket science here. It's just understanding what has to happen when. And so received data, whenever an AR anchor is added, that data will be shared with other peers on the network, other players or whatever users on the network. And so what you want to do then is you want to get the session and you want to then retrieve the collaboration data. Now, keep in mind this word collaboration data because we're actually going to use it in a session delegate method to actually send to all the peers. And so in this case, we're receiving it and we are going to update our session with all that collaboration data. Now, this is a key part. So this here is very important to be able to display what other players are doing. And then what happens here is we're looking, if a peer left for some reason and is now using a different session ID, we want to remove all the anchors that are now stale, right? That have no parent peer anymore. And so that's all that is doing. Again, pretty simple code. Now, what we're going to focus on next is, I have numbers here just because I documented it. Peer discovered. Now, whenever we have whenever a new peer wants to join, this method is going to be triggered. Now, for now, I've limited, or this is really from the sample code too, but it's limited to 4 players. I'm willing to bet that you can increase this number, but you have to be careful that you do too much where there might be lag or latency in the system. So for now, I'm saying, okay, we want to limit the number of players to 4. And I show a print statement. You can have a pop-up or a message on screen that essentially says, hey, you've exceeded your limit. You can only do X number of players. So that's very simple implementation. Now, you don't have to do this if you don't want to, but keep in mind, the more players you have, the network can get congested and might have more latency than usual. Peer joined is when we actually have a new player coming on the network, but not yet connected to all the other peers. So it's not synchronized yet. And so the message now is, hey, someone wants to join. You should hold the device side by side. And there's a reason why you want to hold the devices next to each other. So when you are doing a multi-user session, all devices need to have a shared understanding of the environment, the surrounding environment, and they really need to synchronize their reference frames. So the local device still has their own reference frame, but they also have kind of a joined single reference frame. And so in order for that synchronization to happen, they need to have a lot of overlap in what the camera sees to then say, oh, I know that point, I know this point, I know that point. Okay, this is my orientation and position relative to the other cameras or other devices. And so that's why you have to hold it side by side. And so whenever you open up an app that is a multi-user experience, it will give you or it'll guide you through that experience of making sure the devices know about each other. And so that's essentially what's happening here. And then peer left is whenever a peer crashes or leaves the game or something happens, like even if you open up the control menu, if the view goes into background mode, there's a few reasons this can happen. Essentially, the AR view stops seeing what the camera is seeing. And so what then happens is, this is optional, but you can remove all the anchors that were associated with that player from the current user, so from the receiving user's device. You don't have to do this. You can leave it as is if you don't have to remove things, but this is how you would do it if you want to do that. Now, again, we're seeing some errors here. Remove all anchors is giving an error. And so I'm going to add this method over here. And by now, you know the deal, copy paste. And this is easy code. It's just saying, okay, if you have all anchors in the scene that correspond to the identifier that is from the peer that left, remove all of them. So this is just cleanup. And that's really important if you have a lot of anchors and a lot of players in your experience. Okay, now we're gonna get into, I think, the most important part. And that is we are going to update. Okay, so we're going to send the collaboration data that we have on the device to the other peers. Now I'm going to copy paste this too, but we're going to spend a little bit more time on this because this is crucial. Okay, so it is a session delegate method, and it's did output collaboration data. And essentially what this is, ARKit has now seen that, oh, we've added an anchor, we've added collaboration data that needs to be shared with other participants on the network. And so this is where we do that. We want to make sure that we actually have connected peers. So we want to make sure that we're not just the only user, because then sending something through no one it doesn't make a lot of sense. And so we want to make sure that we have at least, other connected peers. Once we have that, we want to encode our data because it has to be binary data that we send. And so we're going to archive our data using secure coding. Now, I believe this is encryption, and this is required for the RealityKit and ARKit multi-user experience to work. Then we're going to set our data. We're going to send this to all peers. Again, we're going to say reliably. This is set, to critical or yes or no. And if we don't have connected peers, what we're going to do is we're going to defer sending any collaboration data until there's peers. So once the peers connect, then we're going to send it. And that's really important code to know. Again, this is all provided by Apple. This would have been nice if this was all built in, and all we have to worry about is adding objects and everything just synchronizes. When they pitched RealityKit at WWDC, what they said is, as long as you have an anchor entity and you add anything under that or to it as a child, it would synchronize, including physics, including animations. I would like to see that happen at some point. Okay. Now, the final thing we have to do, and then we're actually going to run this. So, as you saw, the part of this tutorial was me writing the basic AR code, creating our assets, animating them, and then adding the multi-user code as an add-on. And so the one thing that we have left is in our previous delegate method, so the did add anchors. Now, we could be done right now, and the synchronization of the laser shots would work. But the one cool thing that I really appreciate, in this framework is that you can actually get the position with real time. It lags a bit, but with real time of the other participants. So the relative position, so you can actually visualize where those players are in the shared environment. And that's so cool because you can have you can do really cool stuff with that. And so the way to do it is we're going to get a participant anchor the moment there's a connected peer in our shared session. And so did add anchors. So this anchor will be automatically added to the scene, and then we can decide what to do with it. Now, what we're going to do with it is we're going to display a red orb for the player location. And so you'll be able to see this move throughout space as the person, with the device is moving. So this is super cool. And so what we're going to do is we're going to say if let participant anchor equals anchor as AR participant anchor. So if we have a participant anchor, what we're going to do is, first of all, this means that we've actually connected with a pair. And so successfully connected with another user. And this is awesome because then you can actually start the experience. So this is where success happens. What we're going to do is we're going to create a anchor entity. And we are going to do it with our participant anchor. So we want our anchor entity in RealityKit to be linked to the participant anchor, because as the participant is moving, the anchor entity orientation and position will also move. And then what we're going to do is we're going to just create a red orb. So this is really super simple. We're going to say mesh resource dot generate sphere. We're gonna do that. I believe that's 30 centimeters or 3 centimeters. And so let color, we're gonna say UI color red, and then we're gonna say material. So there's a few materials you can use in RealityKit. We're just gonna use a simple material. We're not gonna make it metallic. And then we're gonna say, okay, let colored sphere. And now what you can do with this is you can have for each player, it can be different colors. That's what I did with PewPewAR. And so depending on the laser color, you can have the orb color, or you can even have like fancy avatars. I mean, the options are endless. And so, you know, this is really up to you, but I'm just showing you how you would use it. Material. Okay, so now we have that. So what we want to do is we want to add our colored sphere to our anchor entity. Okay, and then when we have that, we want to add our anchor entity to our scene. Oops, add. There we go, anchor. Oh, I can't type today. Okay, there we go. There's actually one more thing that we have to do, and I almost forgot it. What we have to do is we have to enable collaboration on our session configuration. And so what we do is we say config.isCollaborationEnabled to true. If we don't do this, what will happen is none of the data will be sent to the connected peers. And so you'll see the AR view, but no data will be shared among peers. And so it's very crucial that we do this. So just to recap what we did, we imported a new Swift package. I made a helper method, but you can just use Apple's code, where we imported MultipeerSession, which is a helper framework. We created two variables, our session and kind of like an observer, did a setup of our MultipeerSession, and then implemented or copy pasted a bunch of handlers. We did receive data, right? Let's go back. So let's go over here. So receive data, peer discovered, peer joined, peer left, and then we had a bunch of, you know, helper functions to kind of do cleanup and add stuff. And then important to note is that we implemented a did output collaboration data delegate method from the session, where we send all the data to, you know, the connected peers if they were connected. And then most importantly, again, we added our participant anchor. This is where you can have some really cool multi-user interactions. Okay, so now what we're going to do is we are going to run this. I'm also going to show you how to kind of synchronize the devices. We're going to use two devices, an iPhone and an iPad. I'm going to set them up and show you how to synchronize them and essentially show you what we've built. And we'll go from there. Okay, so now I have my iPhone and iPad side by side. And what you want to do is you want to move the devices next to each other in unison and map out the environment. The devices have to get a shared understanding of the environment before they can really, you know, do any multi-user activities. And so now you can see that we have our orb, and so the devices are mapped. And so I can shoot and you can see the laser on my other device going. I hope this video was helpful to you. Now, I am really excited to see what you create. I think multi-user AR experiences are such a novel concept and such a cool thing to play around with. And I can't wait to see what you create. Now, if you want to share what you've done, you know, as a video or a test flight beta invite, feel free to add that in the comments below. If you have any questions about what I've shown you, you know, again, you can ask that in the comments. Now, if you enjoyed this video and it was helpful, you know, a like would really help me out, and subscribe to see more videos like these.